All right. If I were factoring this, the first thing I would do is I would set up my parentheses because I already know how they start. They start with, come on, they start with
X.
X's. Now, again, if that X squared has a number in front, it totally changes the plan of attack. Watch one of the factoring videos that I have to see what I mean. All right. So when I'm doing this, what I'm thinking, and if it helps, you can write it, is I'm thinking that this is the sum, and I'm thinking that this is the product. So I'm not writing it down by itself because the numbers are already there. I just got to identify them. Now, before I even go looking for numbers, I go ahead and figure out the signs because here's what I know. Because the sum is positive, that means that the larger number is positive. So I can take that plus and I can bring it immediately here. And I can make a note to myself mentally or on paper that this is the larger number that I'm looking for. Now, if I know the larger number is going to go there, then I know the smaller number is going to go here. Okay. So whatever larger number I find, it's going to go where I put the word larger. Now let's focus on the product.
That's so helpful.
Because the product is negative, I know that my two numbers have opposite signs. Let me fix this. Because the product is negative, I know the two numbers have opposite signs. And I already know that one of them is positive. So if they're opposite, what does that force the other one to be?
Negative.
So I already know before I even look for my numbers, I need a larger positive number and a smaller negative number. Now I'm going to start breaking down the 72. And here's another trick. Let me start with the 1 times 72. I already know that my numbers are going to have opposite signs. One's positive, one's negative. And when I quote unquote add a positive and a negative, I really have to subtract. So as I'm writing these down, what I'm thinking is which of these will subtract to give 8, not add, because one's positive, one's negative. So I'm thinking in my mind, I got to subtract whatever two numbers I write, they have to subtract to give 8. Now the dirty work. We get out the calculator, we figure out all these problems. I'm going to save you the trouble because I think you know how to do that using your calculator. You've already demonstrated that. So I'll just go through these, and this is what we would get. 2 times 36, 3 times 24, 4 times 12, 6 times, no, not 4 times 12, 4 times, I think I might have messed this problem up. 4 times 18. Uh-oh. 6 times 12, and then 8 times 9. All right. Well, actually, I'm glad that this happened. I'll let you right now. I set up the problem incorrectly, but that's okay. This is the legit problem. I'm looking for the correct pair of numbers. I already know the larger is positive and the smaller is negative. I know when I add them, they have to give 8, but one's positive, one's negative, so they really subtract. Which pair of those numbers subtract to give 8?
Um,
It's a trick question because none of them do, which actually raises a question. And this is worth mentioning, and I'm kind of glad this happened. It's not what I meant to happen, but it's a learning
that means it's
opportunity.
prime. Is that where the
It
whole
means it's prime.
comes in?
Yes, that means it's prime. That's exactly what it means. If none of the pairs work, the trinomial is prime. All right. So this is not what I intended to happen, but it's a possibility. Oops, hold on, I didn't mean to do that. It's a possibility. So I'm going to go over here and answer this question because as a question, it deserves an answer. What I tried to do is give you an opportunity to find the correct answer. So what I'm going to do, actually, let me turn this around on you. The reason it didn't work is because none of these subtracted to give 8. Remember, one's going to be positive, one's going to be negative. None of them subtracted to give 8. So having an 8 in the middle caused this to fail.
Mhm.
Can you think of a number I could change it to so that it would work? In other words, x squared plus a different number minus 72. In other words, change the 8. And remember, the reason it failed is because none of these subtracted to give 8.
6.
Okay, if it was 6, then what would the answer be? Remember, we already figured out that the larger number is going to be positive and the smaller number is going to be negative. Now you said, why did you give me 6?
X plus 12 times x minus 6.
You are already way better at this than you were when we started. Yes, x plus 12, x minus 6.
Well, and the reason I say that is because whatever it has to, that middle number, you have to replace it with a number that the larger number minus
See,
the
now you're
smaller number
you're
equals.
thinking next level, and that's the reason I'm really happy that this tanked. All right, so I'm going to throw it out there again. Besides 6, what other numbers would work? Remember, the 6 worked because 12 minus 6 was 6.
14,
Mm-hmm.
22.
21, but yeah.
Oh, yeah, 21 and 34
Mm-hmm.
and is it 72?
72 minus 1.
Oh, 71.
Right. Oh, you didn't do the bottom pair.
Oh, I didn't do. Oh,
Yeah, 1. Yeah. So you can tell that even with the number as juicy as 72, there's only 6 numbers in the middle that would make it work. And when I set it up, I didn't choose one of them. In my mind, what I was thinking was 4 times 12 was 72, but 4 times 12 is 48. Because the 4 and the 12 subtract to give the 8 in the middle. So it had this product originally been 48, then it would have done what I intended. But I'm kind of glad for this, to borrow Bob Ross' phrase, happy accident, because we got a really productive conversation out of it. Are you feeling better about this topic, Carl?
I feel a lot better.
Good. I'm going to go ahead and stop the recording. Not that there's any benefit to, if I can find where to stop it.